So we are live now. A very good morning to one and all present here. As a humble beginning towards empowerment of our society through technology to create a better tomorrow, the Robotics Society of Birla Vishwakarma Mahavidyalaya presents you Robotics Controller on Arduino Platform using TinkerCAD. I am Kevalya Pandya, second year Mechanical Department and your event host for the day. Imagine, improve, implement. Everything begins with an idea. Ideas provoke the imagination. Imagination thrives the improvement, and this together with proper implementation makes a dynamic engineer. Without any further delay, we would like to invite respected Alpesh Damor sir to welcome and bless us with his kind words.
Thank you, Kevalya. Respected Principal, Dr. Indrajit Patel, sir, Program Convener, Dr. Vinay Patel, sir, esteemed Speaker of Program, Dr. D.M. Patel, sir, professors, and my dear students, friends, warm greetings to all of you. I, Alpesh Kumar Damor, Assistant Professor, Mechanical Engineering Department on behalf of TRS BVM Student Chapter and BVM Engineering College, welcomes you all on one-day online workshop on robotics controller on Arduino platform using TinkerCAD. I, on behalf of the entire team of BVM, would like to thank our expert speaker, Dr. Professor D.M. Patel sir, for taking his precious time out and gracing the occasion with his presence, even though he needs no introduction. Secondly, I want to thank our respected principal, Dr. Indrajit Patel sir, and program convener, Dr. Vinay Patel sir, for giving us their consent as well as the complete creative freedoms. Thank you very much, sir. Welcome, sir. Kevalia.
Thank you, Alpesh sir. Now, I would like to invite respected Dr. Vinay Patel sir to introduce us to the premise to today's subject of robotics controller using Arduino platform using TinkerCAD.
Thank you, Kevalia. Uh, Respected Principal Sir, uh, Dr. D.M. Patel, today's speaker on this particular workshop, faculty members, invited heads of the department of various departments, uh, coordinators of this workshop, student coordinators of this workshop, and my dear student friends. This particular workshop we are conducting almost everywhere since last 3 years. In previous years, we were conducting the physical workshops, especially on Arduino platform. But we know that we are running through global pandemic situations through COVID-19, and the physical gathering is somewhat prohibited. And so we thought of having, you can say, the online workshop of similar kind. And we found that TinkerCAD is a good platform to begin with. TinkerCAD, with the help of TinkerCAD, can have a virtual environment to design a robotic controller for your application, and then you can implement it in physical system. Basically, we are intended to make aware the new students from various disciplines. In this workshop, I think there are students from mechanical engineering, electronics engineering, EC and EL both, CT, IT, various, I mean to say, there is a mixed population, and I can see that new students, I mean to say first year students and second year students are more interested in this particular workshop. And especially this particular workshop is designed for them. I mean to say they want to some work begin with some mechatronic system, electronics and mechanical system. So this will help you to give the what you can say the hands-on the the robotic controller platform. There are various platforms available. Arduino is a very basic and common platform. Then Raspberry Pi, and then there's a Nano and many others robotic controller platforms are available in the market. Uh, in TinkerCAD, of course, only right now Arduino platform is available. Arduino platform is available. Arduino is basically very what you can say the basic robotic controller, and you will find lots of online stuffs on. If you do the Google, you will find lots of what you can say stuff for Arduino platform. And if you start with this workshop, I think you can have better innovative ideas. And of course, TRS is helping. TRS Student chapter is helping to bring out your innovative ideas in the physical reality, and that is our ultimate intention is. So I wish that during this today's workshop, you will geared up to do some innovation in the field of electronics and mechanical and electrical. Okay, so yeah, this may be the new beginning for you, and of course this is a electronics part. We are also planning for mechanical parts also. I mean to say how to design various parts. I mean to say mechanical design that is also in pipeline. Maybe next week or next to next week, we may go for that workshops also using online tools. That is what uh, uh, we are interested to give you from TRS side. I wish once again that you'll have, you can say, the better knowledge today, and I also thank DM Patel to take this particular initiative. Thank.
Thank you
Hello.
so much, Vinay sir.
Uh,
Last but not the least, please welcome Principal Indrajit Patel sir for his presidential speech regarding towards event.
Namaskar and good morning to all distinguished fellow colleagues and participants. Dr. Vinay Patel, the convener, along with his team, Professor Damor, Professor Jayesh, Professor Vijay Pratap Singh, and the student team of this TRS chapter of Robotics at Birla Vishwakarma Mahavidyalaya. This is very exciting. What I heard that students from the first year and second year have taken a very keen interest to join this particular event. And even though they are from the different domains like mechanical, electronics, electrical, and IT, so slowly and very gently, we are moving towards the new education policy pedagogy, which focus on more and more interdisciplinary research, study, as well as practices. So I congratulate Dr. Vinay Patel and his team for taking lead since last 1.5 years. They are working very aggressively, 24/7, establish a robotic lab, have a student chapter of the Robotic Society of India, and then we participated in this DST Gujarat RoboFest 2019, and all our three teams progressively excel till the final round and come out with the first rank at the state level. And again, we are registering for this RoboFest 2020 as per my knowledge. So this is a really a very good achievement. The student teams, the faculty advisors, coordinators and experts putting their effort for nurturing this particular chapter and bringing more and more innovations, bring in more and more students from the campus, not only from BVM, but from our sister institutions also to this particular chapter. I have witnessed a couple of events even during the inauguration of the chapter. Before that also we have one national level talk organized by the chapter, and this will create a very new environment in the focused technology when we are talking about the industry 4.0 and again moving from the cognitive technology to the quantum technology in the era of IT, computer, artificial intelligence, ML, DL, robotics, AR, VR and many more. This will directly or indirectly support the fundamental research in the core domains. Only mechanical, only civil, only electricals will not serve the purpose. Any industries, production industries, manufacturing industries, medical, agriculture, then these what we call the defense, or food processing industries, any industries required now the support of the ITs as well as the recent advances in automation and control. The factories, the production units, which we were looking before 4 to 5 decades, and now we are looking the same production unit with the help of such type of the automation and controls, have really boomed this particular industry to the great extent. And when we talk about the robotics, again, it comes in our mind very late, but we started with the classical robotics mid of 70, reactive paradigm during mid of 80s, hybrid architecture during mid of 90s, again the probabilistic method of this robotic design during mid of 90s and even after 90s also. But once there is industry 4.0 and the era of IT and cognitive technology, the robotics technology, robotics innovation and robotic research has taken 360-degree change in design of the architectures, in controls, in automations and in application. Initially we were thinking that robots are only used in the production units or the manufacturing. Now there is no field left in this technology or the science era where robotics application is not there. We heard about the remote surgery robotics recently in Ahmedabad, the heart surgery, doctor sitting in USA and operating at the Ahmedabad hospital, cardiac surgery. So it is a robovascular surgery. So it is really a blessing to the humankind, to the society, how best we can use this technology. So far as the development or the utilization of the robotics is concerned, Korea is leading with 631 numbers. Out of 10,000 employees, they have 631 robotics employees. Singapore second 488, Germany 309, Japan 303, Sweden 223, Denmark again 189 per 10,000 employee. So this is really, the technology is replacing human being to some extent, but only thing how we can balance the human involvement and the technology involvement, because the sustainability, affordability and future prospect of this growth of this technology is adverse effect on this human engineering as well as the social impact have to keep in mind. So researchers, innovators and developers must think of best we can use this particular technology so that we can balance the involvement of human, we can have optimum utilizations of the technology available with us. The Honda Motors SMO, the human type of the robot is the latest development, as well as the Sophia, the handsome robots, they are most popular in this day. So use of these artificial muscles, elastic cables, elastic muscles, keen, fast moving robots, climbing robots, then the robots who can turn around, even the what we say that the rovers, which we have sent on the moon and other surfaces where a human cannot go. So the robotics will be really a very blessed technology so far as advances is concerned. I congratulate Dr. Vinay Patel and entire team of the Robotics Society of India Student Chapter BVM for taking these leads. And we are blessed with many projects. It is a TQ project, it is SSIP project, our alumni, our management. They are ready to help us whenever we want to commit ourselves in the futuristic development, involving the students, involving the faculties, and making a very huge circumference, family, inviting more and more outside experts, our in-house expert, DM Patel. We look very silently, he's looking very simple, but he has a very huge potential so far as these particular applications, automations, controls, then this Android or Raspberry and other applications with this CAD and other softwares are concerned. So I wish this workshop a grand success. Thanks, Dr. DM Patel, for supporting this activity. Dr. Patolia, as well as Professor Ashish Thakkar, they are also working back to back with this team. So in the future, we will go to the further heights, and Mila Vishwakarma Robotics Society of India chapter will sign at the state as well as national level. May God bless all of us for a better future. Thank you all for giving me opportunity to meet you all on this digital platform.
Thank you, Indrajit sir. And the moment has come. We learn to make the world a better place, and we will start that today itself with our workshop expert, Dipak Patel sir. Welcome, Dipak Patel sir. The platform is all yours.
Yeah. Thank you very much. Thank you. Okay, good morning to all of you. So, just I will share my screen. Please reply me whether it is visible or not. So, please give me feedback whether my screen of the presentation is visible to all of you.
Yes, it is visible.
Yes, sir, it is visible.
Okay. Thank you. Okay, so thank you very much for being with us in this morning, for having the introductory lecture on electronics and robotics controller. Okay, so uh, as principal sir have already given you a brief about the robotics area, so as we have already familiar with the field of robotics, where robotics would be the part of our daily life very soon in the entire world. So we could not escape from that as well. So that is the reason that we have started this group over here as well, so that our students also not miss those opportunities which are upcoming in the upcoming time, right? So that is how we have begun with, and I'm very much happy and glad to giving my thoughts on the introduction to robotics and its controller. So I will share you those things, and this is targeting to the first year students. So, and it is interdisciplinary field. So we thought that every student can begin with this particular platform, and they can start working on this particular area. Also, because of this pandemic situation, we could not have the workshop, hands-on workshop possible in the lab for the students, which we were doing earlier. But due to this online platform, you can have the lot of other softwares are available which you can use directly on browser of internet, and you can remotely also experiment with the hardware. So that is TinkerCAD, the theme of today's talk. TinkerCAD tool that is for simulating the Arduino platform. So those things we will see in upcoming time, right? Anyway, so this is my presentation outline today, where we will go through the basic electronics used in the uh, robotics project, where you may have the Arduino platform. It's one of the platform which we can use to build small robots and related things. We will look at to the Arduino platform as a robotic controller today, as well as we'll look at to the how we can program those platform Arduino platform, and we can interact with that particular software Arduino IDE software. To test our program, we will also look at to the Arduino simulations on TinkerCAD browser that we will see as well. And finally, we'll have the demonstration of the hardware implementation on Arduino platform, so that we can have the idea how things work and all those things, right? So this is the today's agenda of my presentation, so that will go through one by one very slowly. So as it is very first time interaction, so we will go very slowly. So we have the various types of robots that you have heard are the industrial robots, where in industry robots are used to have the some of the industrial automation or manufacturing of the some of the products. You can use robot in all, and car industry you will also find you will find that all the autonomous assembling of the car parts are being carried out by robotics. So you might have seen somewhere in the uh, some videos or somewhere. Then we have the moving robot with the rotational wheel. So you can also have the mobile robot, where from one place to another place your robot is moving by means of the wheel uh, movement. So there may be a three wheel or four wheel, depending on the requirement. You can have the moving robot as well. Then moving robot with multiple legs. So you may have the 4 by legs robots also can be designed and is used in varieties of application in all terrain places. It can move. Then you may have the robot which is like us, that is humanoid, so which is moving by using two legs like we are moving. So such robots are that we can have in around places, right? So these are how the pictures of those things which we had just now discussed. So that those things are I have taken picture from internet itself. So you can see here that there is an industrial robot, a double by robot. Then there is a mobile robot like rover, and you have the multi-leg robots are there. And then there is a animal kind of dog robot, 4 leg robots, and finally we have the humanoid robot picture. So this is how the varieties of types of robots are there in worldwide. Various companies and various organizations, various universities are working on this robotic development and design those things. So research is going on continuously, and far better interesting robotics projects are coming up. So by looking at to this robotic application, you can have one generalized block diagram, which you can derive from the what are the things needed for building a any robotic application. So you can see in this particular block diagram is the uh, what things are needed block diagram wise. So that we are discussing. So here you can see that at the central part or the brain of the any robotic system is a robotic controller. So robotic embedded controller. So which is making your robot intelligent, and entire control of the system is by a robotic embedded controller. So you can see that once this robot, any robot can be provide intelligence by means of the software, and that software is being run by the robotic controller. So like in our computer system, you have the CPU, which is which is there on the motherboard of the computer system, is the brain of the computer system. Likewise, in robotic application as well, there is a brain of a entire autonomous system is a embedded controller. So you can have the that controller can be programmed according to the requirement, and for varieties of application you can provide the intelligence to the robotic system, which is by means of software running at the robotic controller. You might have in mind that how robots can sense or how robots can interact with outside world or with us or something like that. So you will see here that in the another block where you have the sensors are there on the left hand side of this particular block diagram, where sensors are basically required for sensing the environment or some other physical quantity like temperature, pressure, or you may have the strain, and all those things are being sensed by the sensors because they are not giving us this physical quantity cannot directly be read by the controller, as this robotic controller is digital controller, so it needs to have that information into digital data, right? So sensors requires the signal conditioning circuit to make the proper level of the electrical signal. That is, signal conditioning is provided by this particular sensor output, and then analog to digital converter is used for converting those sensors analog output into a digital one, so that your robotic controller can understand and sense the value in terms of digital domain, so that based on that sensor, it is taking some decision in algorithm of the robotic controller, and then it doing some further task. On the output side, you can see here that there is a driver part is there. So driver is basically system which is responsible for driving the actuators or motors which are part of our robotic system. So basically, your robotic controller is not capable of driving directly the actuators or motors, but it requires a driver system to enhance the appropriate voltage or current level to drive the actuators, which is actually used in the robotic system. So there is a driver which is taking input from the robotic controller output, and then it converts the appropriate voltage level into actuators requirement, and then it generates the signal that to drive those actuators. Right. So this is how basic blocks you will find over here in the our robotic system, and also other things like power supply block. So entire robotic system requires power that is being driven by the battery, or it may be have the power supply is taken from the our supply outside. And you may have also camera which is used for vision based application for the robotic system. So, and as well as it is also having some input system for giving some information like touch screen, or you may have the keypad. Such systems also you can have to be interfaced with our robotic controller. As well as there is a memory requirement in the robotic system where you can have the storage of the program, the intelligence of the robotic system being provided through the software, and that software code is being stored in the program memory of the robotic system. So that program memory may be part of our embedded controller, or it may be externally interfaced with our robotic controller, right? So that is how the memory part is essential in case of the robotic application, like our computer system requires it. Uh, Also, our robotic controller system is essential to communicate with the other system, like our computer system or the internet, or maybe with the cloud platform, or maybe local LAN. Such things are needed. So there are network protocol must be supported by our robotic controller. So that is how you can communicate with our robotic system, and there may be a wireless channel, so that you can wirelessly interact or communicate with our robotic application. right? So this is how you can derive this particular block diagram for the robotic application. So it is called generalized block diagram, as we are not targeting it to a specific robotic category, but we are having the broadly you will find this particular system you will locate on the any robotic application. Right? So I think it is quite simple, and it is as good as our computer system, but little bit specific to the robotic application. So we may have not entire computer's block diagram, but it is look like specific to the robotic application. Right? Now, what we had seen about this block diagram, we'll just go into a little bit deep into this particular block diagram. So, depending upon the types of robotic input required, sensors are required. So, these are many few sensors types which are used in building robotic sensing activity. So there may be a position sensors you can have on the movement of the some of the robotic part, where potentiometers are the position sensors used, and limit switches are there which sense the metallic object, and such sensors you can have for having the position detection of the some movement of the robotic uh, part, right? And then there is a detection sensor also, where you can detect the some of the positions at which position your robotic part is. That is to be that can be decided through a IR sensors or proximity sensors or touch screen sensors. So such sensors are also you can use for detection sensors. Then there may be a position detection of the particular point on the robotic system. Yeah, you can use accelerometer, gyroscope. So it is giving you the three-axis movement detection, and your robotic controller can take decision based on that particular position detection through this particular sensor. There may be a feedback sensor, so you may have the suppose if you are driving the motor of the robotic system, then you need to also check the feedback whether it gets rotated as per the required targeted, and then you can read back that particular generated speed, and you can read the feedback for having the speed measurement and all those things. So feedback sensors are the encoders and tachometers, and such sensors you can use for having the feedback of these motors and all those things. Then there are camera sensors for image vision. So image processing. Suppose if you want to detect some of the objects through your camera, then you can have the camera interface with your robotic system, so that you can capture the image and you can process that image, and you can take some decision whether some object is there or something like that, or you can recognize some of the objects for your application. There may be a chemical sensors for detection of various chemicals, like you want to sense the gas or something. So for different applications, you can go for different varieties of the sensors for various purposes, right? So that is how you may have the sensors of these chemical types. Then there may be a common sensors, temperature sensor, pressure sensor, humidity sensor, flow sensor. So here and there you can go for select this particular sensor for having your robotic application. So we can have the sensing of the particular physical quantity, and based on that you can take some decision for your algorithm of the robotic. Now, as we have discussed about the signal conditioning part in the block diagram, so there may be a chances that the sensor output is having very low signal strength, right? Because the sensors generally not giving you the that much strength of the signal, so that it can easily be recognized by the controller. So you need to have some of the signal conditioning circuit for modifying the signal output from the sensors. So there may be suppose low signal strength, then you require amplifiers to amplify that particular signal to get it exactly correlate with the input variation of the physical quantity, and you can readable those output of the amplifiers easily, so that your analog to digital converter can convert into a digital one very efficiently. So you require amplifiers for enhancing the amplitude of the sensor output. There may be a noise filters required. So there are many times that lower signal strength are also corrupted with the external noise, like your power supply noise and many other noise and in the industrial environment that needs to be filtered out, so that your original signal output, which is of low signal strength, does not get corrupted, and exact required signal needs to be processed for your converters, right? So that is how you require the signal conditioning for amplifying and filtering of the signal. So many times your sensors giving you the signal is of high signal strength, right? So that also not uh, good for the analog to digital converter to convert it those data, because the your embedded controller is working on very low voltage DC voltage, and suppose your signal is beyond that supply voltage of the system, then there may harm the system. So you need to reduce those high output signal from the sensor. So you require attenuators over there to attenuate that signal level. But of course, you can take calibration in the software to have the one-to-one relationship between your sensor output and that attenuated output, and you can calculate exact value of the sensor output to be uh, calibrated, right? So that is how you may have the attenuators required for high signal strength, and the noise filters are also required over here, that may also correct some high uh, uh, output signal which has been filtered out by the filter. So now next stage is analog to digital converter. So it is basically a conversion from continuous domain sensor output into a digital domain data, because our embedded controller only process the digital data. It is a digital controller basically. It's like our computer system where your microprocessor is behind the motherboard, and it is doing all digital processing. Likewise, the embedded controller also process the digital data. So to understand the sensor's output, which is in continuous domain, requires to convert into digital by means of analog to digital converter IC. So IC is an electronic circuit which is responsible for doing that particular job, right? So this is how the ADC, which is part of our entire block diagram of the robotics controller system. You can see some of the pictures which is already available in the market of these particular peripheral ICs. You can see here that there is analog to digital converter IC available, which is from National Semiconductor M56AN. So there are varieties of the ADCs are available in the market, multi-channel ADC. Then you have the single channel ADC, 8-bit ADC output, 10-bit ADC output, 12-bit ADC output. So depending on the requirement, you can choose this peripheral to have the analog to digital converter functionality for our robotic application. In nowadays, latest embedded controller have also on-chip ADC available, so that you need not to have extra ADC interface with our controller for sensing the sensor output. So that is how the integrated circuit look like physically, that you can buy from the market, and you can connect for your connect the into your electronic circuit for having the ADC requirement. Then there is a operational amplifiers picture is a LM358. LM358 are the popular amplifier chip available in the market, that also readily available. So it is actually internally integrated circuits fabricated in a single IC, so that you can easily connect in your electronic circuit to fulfill the requirement of amplification. So likewise, you may have the dual operational amplifier ICs also available, LM1458. So these are the some of the components which I have shown you on this slide, so that you come to know that how the ADC look like, or amplifier look like, or how the circuit ICs are look like. So this is how you can easily search on the internet, and you can get that data sheet information about all those components that are available, right? And you can get this information at one number pin or two number pin, what is the information, and all those things you can study and you can use for your particular app. Now let us talk about the our central part, that was the our digital controller. So basically, a robotic controller may be part of our robotic system. You can use the entire computer system, PC, personal computer, through which also you can control all robotic accessories. But you can see here that bulkiness of the computer system increases the sizes of the your robotic application. So it is also possible to reduce the some of the uh, specific application size of the system. So you cannot use this PC whole PC for your robotic application. Likewise, you may have the also programmable logic controller system available in the market to drive some sequential operation. So your robotic application can also be driven by programmable logic controllers. But again, it is designed for specific application of industrial application. So not all the functionality of robotics can be fulfilled by PLCs. So you can also not very much use in the robotic controller. But recent trend is use the embedded controller. So embedded controller is basically a small size platform which you can have fulfill the requirement of your robotic system, and you can use for your robotic application. So and other side also you can have the low cost solution which fulfill the requirement of our robotic system. Then you need not to hire the entire PLCs or entire computer system to control your robotic application, right? So that is how the embedded controller is basically a robotic controller that we are going to discuss today in our this discussion, right? So that is how the embedded controller. So embedded digital controller is basically uh, microprocessor with some of the minimum peripheral available on chip, right? So it is called microcontroller. So there is a embedded digital controller is designed with microcontrollers. So microcontrollers are available in the market nowadays with very low cost, so that you can control the entire uh, system of the robotic application through that particular controller. And the cost of that controller is also very low cost, very few hundred rupees you can get that microcontroller available, and based on that microcontroller you can have the your embedded controller, robotic controller design is possible. So you can reduce the cost of the controller and can have the performance optimization depending on the requirement you can go for. Also nowadays a lot of vendors or various companies are manufacturing this microcontroller with system on chip capability. So it is having on chip ADC, on chip DAC, on chip peripheral ICs, memory are available, and the data handling capacity also improved lot. 32-bit ARM processor is also very much popular in the designing of the embedded robotic controller. There may be a programmable controller also available, which is FPGA piece of where you can control your own choice of putting the component into the hardware and can use as per your requirement, right? So that is how the latest development also going on in the robotic controller application. Then there may be a digital signal processor dedicatedly used for handling the signal processing activity like image processing you can handle, then audio speech processing you can handle efficiently through DSP controller. So you can build your embedded robotic controller through DSP processor as well, and you can get the advantage of all the signal processing activities in the robotic app. Then there may be a latest development in the embedded computer, that is OS based embedded controller, which is carrying our operating system on that board, so that you can feel like you are working on computer. So latest example of those embedded controllers are Raspberry Pi and BeagleBone, Galileo board, Panda board. So such boards are basically a card size computer. So you can have the limited resources which are sufficient to use for robotic applications. So not entire computer is required to handle the robotic application. So operating system based pocket size computers are available. Raspberry Pi is among them, is very popular nowadays, and it is very cheaply available in the market. It is costing around 3,500, and you can get it very easily, and then you can start working on that. So basically, you can get all the advantage of operating system which you are already experiencing on the Windows or Linux platform on your computer system, right? So this is all about the embedded digital controller, which can be used for having the our robotic application activity. Yeah, so intelligence of the our robotic application is to be fulfilled by the embedded digital controller. These are some of the embedded controller boards available in the market. So you can see in the picture that there is an Atom processor based robo board uh, robotic controller, which is from the Intel. Atom processor is from Intel, and there may be a third party vendor who have manufactured this robo board robotic controller. So the size of that board is not much, is 5 centimeter by 5 centimeter size, and you can have the central board controller. Then there are GPIOs are there, the input output connections, and then there is a serial port is there, power jack is there. There is a varieties of the boards are available. So depending on cost, depending on your performance requirement, you can go for those boards. Basic stamp 2 module is also a microcontroller, a big microcontroller from microchip company, and it is very small size board is there for for the application of the robotic system. Now let us talk about some of the actuators that we have seen on the our generalized block diagram of our robotic system, where you may have the motors are there, which is basically used for various movement used in the robotic application. Say for example, in an industrial robot, you may have the some arm movement that you can carry out through DC motors. You can go for stepper motors, and there may be other types of motors like brushless DC motors, servo motors are there. So these motors are basically used for various application. Like suppose if you want some high speed application in drone application, you can go for BLDC motor. If you want some movement, slow movement with high torque, then you can go for stepper motor. And for having normal very simple movement of the motors, then you can go for DC motor or servo motors. Likewise, so depending on the requirement of various parts of the robotic movement, you can go for selection of this motor. And to drive this particular motor, you require motor drivers. As I already told you that your motors cannot be directly driven by the digital output of the embedded controller, but you require drivers in between your motors and your digital controller. So you require DC motor driver circuitry, H-bridge IC, or BLDC motor drivers, or stepper motor drivers, or servo motor drivers. For driving such high power requirement supplied to the motor, motor drivers are required in between, right? So this is how the actuators generally you will find on the robotic application the motors, right? And motors and relays, many times relays are also be used for having the various. So it is basically a simple DC motor. You can have, for example, you can have the single battery DC motor driving activity. In the childhood, you might experience with the toy motors to connect with the battery, and you can have two leads to be connected on the motor to terminal, and you can rotate the motor, and that excitement you might have observed in the childhood. While you can use two batteries for both the direction movement, or you can invert the terminal and you can change the direction of the motor. Single battery for both the direction control. So DC motor can be controlled through your embedded controller digitally. How we can do that? Just now we will see after our discussion is over. I will just show you how we can control the DC motor direction, speed, and how we can use the drivers for having the driving of the motors. So basically, pulse width modulator technique is used for driving the speed of the DC motor by means of changing the pulse time bit. So that is basically a duty cycle. You can change the pulse that we will discuss very soon about this, how we can control the voltage proportional to the driver requirement of the DC motor speed. There may be a various algorithm, that is proportional integral derivative control PID can be implemented in the software, but at this stage it is not essential to look into those PID things to get it controlled movement of the motor station. So that part at this stage is not essential. At least you should be aware of how to change the direction and how to change the speed. So that knowledge only essential. So we will also discuss this part later while we discuss about our board. Then we have the stepper motor as well, also used as actuator part in our robotic applications. So you can have the high power digital sequence. So basically, stepper motor is to be controlled in the open loop manner. So you will not require feedback to sense the speed, because to drive the stepper motor, a particular logic sequence that you need to provide at the input of the stepper motor with high current capacity pulses. And by calculating those pulses, you can calculate the speed as well as the direction of rotation. So such things are possible in case of stepper motor. So the driver development for stepper motor is a bit busy. So you will also come across this driver IC available in the market to get it controlled by our digital controller. Right. So that is how you may have the stepper motor requirement. Now you can have the software development for our robotic controller as well. So you may have the simulation on Proteus simulator with controller, or you may have the electronic design automation tools. Software tools are available. So those who have manufactured a controller, they are also providing these autonomous tools. So you can develop the software for that particular controller, and you can get it work that particular controller, because every controller board requires the software to run on it, and that software is to be developed by EDA tools. So that is how you can have these various software. So there are a lot of tools are available depending on the controller used, like Kale tool is there, Arduino IDE is there, Vivado software is there, and it supports the higher level language like C, Python, Perl, or Java. So in short, you can program these boards programming in C programming language, or in Python, or any other programming language. Arduino platform have its own programming, that is C++ used for development of the program for Arduino. But it is very simple that we will see in the programming part of the Arduino board. Then there are graphical programming language also there in the market nowadays, as the software development is also going on parallelly, where you need not to write any code. You simply drag some of the blocks and you can get ready your program on that particular tool. If you are using PLC for your robotic application, then there will be a ladder diagram programming. So it is again the graphical way of doing programming the PLCs, and the sequential operation you can program and you can get your job done, right? So this is how few of the software tools which are there responsible for development of the software for our embedded controller. Electronics hardware development boards are uh, there in the various controller platforms. Like Arduino is popular one. Then Raspberry Pi is there, as we had discussed. Eagle board is from Texas Instruments. Mango board is from Microchip company. Freedom board is from Freescale, and Discovery board is from ST Microelectronics. Intel Galileo board. So these are the various boards popular available in the market. You can buy those, and these are all low cost boards. So you can see that it is like a computer motherboard, but it is a small size computer motherboard. So you can buy it with less than 10,000 or 5,000, and you can use for your robotic application. So these are the various hardware platforms which you can purchase from the market, and you can start working on that for the robotic application. So I think we have just gone through the basic blocks of the robotic application. So you guys have some of the idea what is the building blocks of the robotic system. So before we begin the next session, I would like to have just 5 minute break. So then we will start new slides on the Arduino platform. So currently 12:27 sir. So we will start with 12:35, right? We'll start with 12:35 for this little break. Thank you.
Hello. Hello. Yes, I just take an opportunity of this little break. I think DM Patel is preparing for something that is for the next session. I would like to appeal all the students to become the member of student chapter if you are not a member. Hello. Hello. So I appeal to the students. Hello. Yes.
Yes, sir, you are audible.
Yeah. Appeal to the students to become a member of this student chapter of the Robotics Society. Thus, becoming a member, it will help you as well as the chapter and as well as society. So it's a mutual, what you can say, the understanding, and Likewise, we can have, if our student chapter is strengthened more and more, we can have a better and better workshops, seminars, webinars, activities like competition activities, like we are participating in good cause. We are also planning to participate at national level and international level. So this will help the student chapters of BVM, Robotics Society, and as well you. So regarding this membership information, I think purely if you have membership information, I mean to say how to become a member and what are the uh, what is the fees you can display during this break. And I also request anyone you have a video of rover which we have made for I think presentation, so that can also be played. Thank you.
Yes, sir. All the videos have been uploaded on our YouTube channel. You can go there and see. Also, all the information is available on our TRS website, so that will be available over there as well. And I will also put every link in the chat box as well.
Yes, good. This is the particular rover we have built last year, and it has secured first position in the rover category. Of course, jointly with the GSAT.
Okay, so shall we start? And is my screen is visible to you, all of you?
Yes,
Yes, sir.
Okay, okay, fine.
Yes, sir.
So, yeah. Okay, so I think we'll continue with our discussion on the uh, embedded robotic controller for having the robotic application. So the hero of our today's talk is Arduino Uno development board, with which you can begin with our study of the robotic controller. So it's basically a development board. So what is microcontroller that we have understood in the earlier discussion, that basically a microcontroller is nothing but a computer in a single chip, right? So whole computer is not possible to fit into a chip, but some of the peripherals which are essential for having the computer based application, you can have the controller. So microcontroller is containing the microprocessor, then memory, program memory, RAM memory, analog to digital converter into a single chip, and the size of that microcontroller is very small, and you can have the lower cost availability from the market, and based on that you can have the your embedded uh, robotic controller you can develop. So typically embedded inside some devices that they can control, and we can build a system. So it is known as the microcontroller. So various peripheral are part of a single chip is known as the microcontroller, and the cost of that microcontroller is also very low compared to the external microprocessor available in the market. So if you compare the microcontroller cost and the processor cost of the computer motherboard, is very huge difference. So microcontrollers are available in the market is around 100 to 500 rupees, while microprocessors like Intel i7, i5, such processors are available around 6 to 7,000 rupees. Right. So that is how the cost comparison as well, and not entire microprocessor is used for your robotic application, but you can fulfill the requirement with the lower uh, uh, size and lower cost processor for having your robotic application. This is how the Arduino platform use this microcontroller. It is from Atmel company. Atmel AVR at Mega 328 is the microcontroller number, which is manufactured by Atmel company. Now it is been acquired by the microchip company. So it is now termed as PIC microcontroller. So this microcontroller is at the center of your Arduino board. So you can have that AVR at Mega 328 chip is there in the Arduino platform. So it is containing memory, flash memory, RAM memory, EEPROM memory, timers, counters, then serial UART, interrupts are there, analog to digital converter, analog comparator is there, then input output lines, so that you can interface with this particular microcontroller through various peripherals. So you can see on the left hand side there is a pin details as well, which you can find from the data sheet of this particular microcontroller, and on which pin which are the connection are there, it is been explained in the data sheet, as well as you can refer to the pin details of the this particular microcontroller. So this is a microcontroller chip Atmel AVR Atmega 328, which is used to build the Arduino Uno platform, which we are going to discuss. So this is how the Arduino Uno board is also known as development board. So it is basically a printed circuit board designed to facilitate work with particular microcontroller. So generally the microcontroller based small development board is available at very low cost, so that anyone can buy and they can work with this particular development board which are available. So here your microcontroller based board is looking in this picture, which typically requires a power circuit inside that. Then there is a programming interface, the serial port, USB port is there. Then basic input, usually buttons and LEDs you will find on this development board. And there are I/O connections, I/O pins connections, so that you can connect various other peripheral to that particular board through this connection. And adjacent to this board, there is a picture of breadboard, which is provides the user to various connection requirements. So you can have the that breadboard have the connectivity between various vertical and horizontal connectivity, so that you can insert various wires to have the connectivity with the various peripherals. So this is how the your Arduino Uno board look like, where you will find there is a digital input, digital output pins, PWM, PWM pins on pin number 3, 5, 6, 9, 10, 11. So on the PCB itself, you can see these numbers 0, 1, 2, 3. These are the GPIO ports are there. This is our microcontroller at Mega 328 available on Arduino Uno board, and there is a power pins are there where you can have the reset circuitry, 3.3 volt, 5 volt, ground, in is available. So, and there are analog pins, analog input, digital input or output pins are there also on Arduino Uno revision 3 board from Arduino organization. And there is a USB connector as well, so you can connect the USB cable to your computer system to develop the software on the Arduino platform, right? And there may be a adapter supply, 9 volt DC, which is to be connected on the supply adapter to get it this board supply. So if your USB connection is not there, then you can program that board and then you can use it with the power supply, external adapter power supply as well. So this is how your Arduino platform look like, which is also available in the market with very low cost. So cost of this board is around less than 500, 450 rupees or so. You can just search on Amazon and all those things, so website, online store. You can get this board very cheap, and you can have your own development board for working with this particular. Uh, and this is open source hardware, so you can also have the circuit connection as well. It is available on internet. So now, what is the Arduino platform? So basically, it is an open source hardware and software development board. So the hardware schematic is open source, for anyone can take that schematic. If somebody wish, you can modify that schematic as well, and you can redesign based on that particular Arduino platform. So hardware schematic is open source, as well as software is also not required any licensing. It is an open source platform through which you can program this Arduino platform. So you can have the lot of software examples are readily available with this particular Arduino software, and lot of libraries are also open source. You can get simply those libraries from internet and you can club into your development, and then you can take use of the entire library portfolio available on Arduino platform. So the resource of this Arduino platform is available on website www.arduino.cc, where you will find a lot of examples and lot of projects are there, lot of libraries are there that you can download and you can run in on your platform, right? You can have the various peripheral sheets are available for various applications like sensor board, sales and actuators, board, sales, displays, boards, drivers, touchscreen drivers, shields. So these are the additional accessories needed to build a complete application, and those can be drag and drop kind of thing. So you can simply use, let us say, for sensor shield, then you can buy that sensor shields and connect on your Arduino platform, and you can take sensor based application activity on that platform. So likewise, varieties of seeds are available, and it is made by various companies even. So you can have the choices available in the market. That lot of companies are making these seeds, which is Arduino compatible, Arduino compatibility, right? So you can take baseboard as Arduino platform, and those seeds are from the different vendors, depending on the application, varieties of applications you can go for. So under any vendor-specific device hardware provides the library functions available to work with this Arduino platform. So this is the great thing that the third-party development of the shields are providing readily available libraries so that you can import those libraries, and the function of those libraries you can readily use in your development by incorporating this particular fields. So that is how the powerful resources are available worldwide on internet that you can use for your Arduino platform based development, right? These are the few varieties of the Arduino platforms which are launched by Arduino organization. That is Arduino Uno is a very basic board, then Arduino 101, Arduino Pro is there, Arduino Micro is there, Arduino Pro Mini is there, Arduino Nano is there, Arduino Mega 2560. So depending on the capability of the board requirement, you can go for this Arduino platform, and there is a versatility in all syntaxes of the library platform of the Arduino software. So you can choose any one board as per your requirement, and you can have work with that particular one unique software, Arduino software, right? So that is the varieties of the hardware capability boards are available at different prices. Say for example, Arduino Mini Pro is very low cost board is there with the limited IOs and limited resources on that, so that the cost of that is very low. And so depending on application, you can go for this selection of this board to get it work your done the job work done for your application. Now we'll go a little deep inside this Arduino platform. It is Arduino Uno with the detailed resource availability on that particular board. So it is having the reset switch is there. You can just reset your board by pressing. Dropout regulator IC is there. So basically, many of the peripherals on board are working on 3.3 volt. So 5 volt is converted into 3.3 volt by this regulator. There may be a USB jack, then your USB to serial IC is there, which convert your USB port into a virtual serial port where you can have TX and RX pin available on this particular board. And then there is a one LED is there, which is connected on pin number 13 of this Arduino platform. So which is by default given by the Arduino developer for testing readily test their LED blinking program or some testing program that they want to do without any connection you can have on Arduino platform, and then you can take check the status on that particular platform by enabling this LED through software, right? So this is how the these detailed uh, peripherals available on basic Arduino development board. It is having the digital I/O pins and analog I/O pins where you can have the analog data you can send through analog channel, and digital data you can take from the digital input output pins on the Arduino platform. So what we can do with the Arduino platform, so that we can have so quickly able to prototype a working project, right? You can buy this particular board from the market. You can connect from some peripheral sensors, and you can quickly able to do prototype. So it won't take much time while you buy and interact with this particular board. It will take hardly half an hour to make it work, this particular. So you will see that how we can make work start with this particular board. It able to produce a working computer system, right? So whatever you wish to take job from that particular board, you can develop the software for that platform, and you can make that computing system very handy, right? So that is how you can do it very easily. The tactile feel of assembling a project is very rewarding, making something that works, right? So the feeling is like, suppose you are wishing to happening something on board, which is actually a date machine. It is not live machine, but you can make as per your wish, that you can do with this particular board. So your wish you can convert into your Arduino syntax software, and you can burn that software into the platform. So whatever you wish, you can take job from that particular board without your any interruption or any uh, uh, support, right? So it is basically an intelligent device which is uh, carried out by the microcontroller inside the board, and whatever your program written based on that program, it follows, right? So that is how autonomous things you can. So ultimate goal is to have the our robotic application is to do some activity by a robot. So that is possible through such type of boards by programming it. So as per your wish, your system behaves, right? So for that, what I believe is that learning by doing approach you can follow. So suppose if you want to learn a robotic controller board, then you can start doing some of the activities with the robotic platform. So as we have discussed that Arduino platform is very popular and it is open source. You can, and it is low cost, so you can easily buy and you can start working with that. And by doing that, you can learn the things how it is going on. So later, if you want to upgrade your system, then you can go on hiring other advanced board and can easily migrate to the that particular advanced controller board. And by this you can learn the things, right? So this is learning by doing approach you can do. Building small project prototype, you can have small working project to Arduino platform. So you can show the proof of concept to the some industrial person, where you can show some proof of concept that how these things is going to behave, and all those things you can do very easily. And we have the demonstrating the Arduino project within small short time period. It is also called time to market. So suppose if you are starting some project and you are involving in designing and all those things, so that takes much time, designing, fabricating, manufacturing. Such things are taking much more time. But if you want to just simply develop the project based on Arduino platform, you can simply carry out time to market by learning and by procuring and by developing. You can easily launch your project in very short time, right? So this is how you have the Arduino project advantage that we can do through our quick development. Some of the basic components you can begin with. So you can have the LEDs are very popular, which you can see, and you can enable this glow this LED through your Arduino platform. So lots of LEDs with variety of colors available in the market, which requires one small tiny resistor to limit the current to make it work this particular with your Arduino platform. And the cost of these LEDs are also very low, 1 rupees per piece or something like. So 10 LEDs costing you 10 rupees to purchase it from the market, and you can make something that gets exciting to may work with. So good for blinking, dimming using PWM, night rider effect with 8 or more LEDs, strobe effect, etc. So you can connect the LEDs with the board, you can develop the software, and you can see the effect, how this LED can be make blinking or maybe some activity that you want to carry out. Then there is a display devices, small display devices is popular in our embedded platform where it is known as liquid crystal display LCD screen with backlight. Yeah, it is displaying basically a 16 cross 2 line characters is common and teaches the complications of the axial display. So you can see here in the picture that the 16 characters you can display, and in the two lines, so there are total 32 characters you can have the message. So suppose if you want to display something, let us say temperature value or pressure value or speed value, then you can display so that user or developer can come to know that what is display, how we can use it. So in our computer system also, we are using a monitor to get the output of the program and display on screen so that we, the developer of the software, can able to see that the response of the our platform. Right. So that is how you can have small liquid crystal display which is used for interfacing with the Arduino platform as well very easily, and you can develop the program for displaying something on LCD also possible. The instructions for how to connect is built in a sample sketch in Arduino itself, and students get a huge degree of satisfaction from transmitting text to the LCD screen. So once you interact with this component through Arduino platform, and whatever you wish to display on that screen, it is quite easy to do that, and you will also find a lot of excitement while it is getting displayed. So it is a first lifetime experience that you might have. Very soon will interact with this particular component. This is how you can make connection with this particular LCD display with the Arduino platform. So we can see here that there are power pins are there, then there are control pins are there, and there are data lines are D0 to D7, and two of the backlight LED connection is there. So this is physically connection with wires required to this LCD as per the data sheet of this LCD, which you can download and study. So this data sheet will give you the information about the all pins available on the LCD. You can connect with your Arduino platform, and you can make a program on Arduino software to get it display something on the LCD. But these are the hardware connection required while you want to actually do some physical activity on the LCD screen, right? So that is how you can have the connection. So I'm showing you simply an example. In the software, I will let you also know how the program can be developed. This is how the sensors look like. Basic temperature sensor and humidity sensors available in the market with a very low cost. DHT11, DHT22 is a popular one is available, and the library of those sensors are also available, so that you can simply download Arduino library and you can incorporate into your platform to read the temperature and humidity at the output. So you can see here in the 4-pin connectivity with the this DHT sensor. One is VCC, that is 5 volt, then there is a data output, then not connected pin is there, and there is a ground. So if you made 3 connections to the Arduino platform, and you can develop the software by downloading the library, you can display the temperature on the LCD screen. So in this picture, you can see here that there is a connectivity of DHT sensor with Arduino platform. 2 number pin is connected to data pin. Ground is connected to ground pin of the Arduino platform, and 5 volt is connected to the VCC. And on the right hand side, the picture will show you one Arduino platform. Then there is a various wires are there, connection wires are there, which are made from the metallic material like copper or aluminum. So these wires are connected with this particular pin as per this schematic diagram, and DHT sensor is connected and LCD is connected. So you can see that you can develop a program in Arduino platform to have the humidity and temperature display on the screen. Well, and the sensors is also connected. So, and this is on the white color system is there, which is known as breadboard, which is used for making various connection, and can disconnect and connect like very easily. So you need not require any electronic soldering for having the permanent connection. So it is used for various purposes. So connection is for this application, and this is small blue color middle a picture is shown by this particular figure is the resistance. So resistance is basically a resistance that you can have. It's a restrict the flow of current with some amount, control amount. So that part is also look at in this particular picture. But in short, what I mean to convey is that the physical connection requires as per the schematic diagram, which you can study from the data sheet of the sensors and your Arduino platform, and you can make connection with wire, and you can develop the program, and your output is to be generated on the display devices. So this is a small system, temperature and humidity monitoring system that can be seen in this particular picture by having this particular connection. Then there are some actuators that we will see, that small servos are the servo motors. This is the picture of servo motor, which is used for doing some movement of the your robotic application. So Arduino can be used to position servo at given angle for use in projects. Other sensors can be attached to the servo to add a layer of complexity. Servo library is also available, which you can download into your software, and you can make this particular servo motor work. So you can see in this particular picture that left hand side is the schematic diagram of the servo to be interfaced with the Arduino platform, and there is one potentiometer is there. So that potentiometer you can vary, and you can control the position of the servo motor. So in right hand side picture there is one dialer is been designed. Behind to this dialer you can see there is a motor is connected, servo motor is connected, which is driven by our Arduino platform, and the status of that is being displayed on the LCD, right? So LCD display giving you the digital display information, while you can design some of the meter like with one arm and showing the reading value as per the your current value that you want to display. So analog type of meter you can design through your Arduino platform and servo motors for such an application, right? So this is how it's just giving you idea that how we can convert that schematic diagram into physical wirings of the your Arduino platform and get your things work. This is the ultrasonic range sensor is there. So ultrasonic it's basically used to in robotic application, ultrasonic sensor is used to detect the object and the distance between to your obstacle which is in front of the robotic application. So it uses the ultrasonic waves to determine the distance between sensors and objects based on the time between emission of wave and echo of it. So by calculating that difference between the transmitting and reception, you can get the idea about the how far that object is available on the sensor front, right? So the good for introducing discussion of speed of sound variation in with environment conditions. So depending on the environment condition, the speed sorry is also varied. So calibration principles are easily been derived for this particular sensor. So this is how we can connect the ultrasonic sensor with our Arduino platform. So you can see here that there is a VCC, ground is there, then trigger pulse is there, and echo pulse is there. So you can connect trigger to one of the pin and then back to the another pin to the echo, and then you can write a software by calculating the trigger pulse and echo pulse and determine the distance that it gets. So by measuring the difference between the transmitting and receiving pulse of the ultrasonic signal, you can get the dimension of the distance of the obstacle, right? So this is how the physical connectivity required for having this ultrasonic sensor. Now we'll look at to the how motors, DC motors can be interfaced with driver. L293 is a driver chip available in the market, which is used for driving DC motor with Arduino platform. So you can have the there are input for L293D motor driver, where one signal is the control signals, then there is a bidirectional signal which decides the direction of the signal, and there is a pulse width modulator output which decides the speed of the DC motor. So by writing software in Arduino platform for controlling the PWM width, you can control the speed. You can change the direction by controlling bidirectional pin, and you can have the control signal to whether select you want to have the 1A or 2A selection. So depending on the datasheet description given into the L293D driver chip, you can study and you can interface with your Arduino platform, and you can write a program to run your DC motor. So DC motors are basically very much used in development of the various robotic application, where you want to move some arm or you want to do some movement of the wheel, and all those things is possible with the DC motor driver. So basically, it is very much used this particular motors in the robotic application. So this is how we can interface the motors with the Arduino platform in the hardware. Which are some other components that are relatively easy to use? There is one graphical LCD also available, which is displaying the graphical image on the display, as well as textual image is also possible. So you can purchase this graphical display from market, and you can develop the program by incorporating the libraries, and you can display some image on the graphical display. But the textual display LCD screen that we had seen earlier, which is not capable of displaying graphical image, but this LCD, this graphical display is capable of displaying the graphic image, so that you can incorporate in some of the applications. This is some other modules are there. GPS module that can be used for varieties of purposes, such as triggering responses only when the user is standing in a particular location. So GPS tracking is possible with this GPS module. So in your robotic application, suppose if you want to track the robot, you can get these module ready with, and we can incorporate in the robotic application. This is the relay module also available. So there are multiple relays you can have interface with your Arduino platform to control the high power supplies by using the Arduino platform. So it is also used for some of the robotic application where you want to control the some of the motors through relay. It is possible with this. So this is a relay control card is available, and you can incorporate into your design. Now, what are the resources that you can get from internet? So you can visit the website arduino.cc, information on hardware, some libraries, and sensors for the integrated development environment, and reference material on the commands and structures. So this is how you can have the resources available on this particular platform. A lot of other popular websites are also there for such DIY. DIY stand for do it yourself, right? The DIY stand for do it yourself. Many of the students are knowing that thing. So one of the website is instructables.com. You'll find a lot of projects available. Arduino based projects are available, which they are giving codes and libraries that you can download and you can incorporate in your application. So such websites are there. Then McKinsey.com is also there. It is home of Make Magazine, which has lots of Arduino projects. So you may visit this website for having the resources for the Arduino platform. So these are some of the Arduino books are there, which is used for development of the Arduino based projects. So Arduino programming by Simon Monk is there. Arduino workshop by John Voxel. Exploring Arduino is from Jeremy Blom is there. So these are the some of the books, reference books that you can find in the libraries of your organization, our organization, where you can have the development of the Arduino based projects and all those hardware software discussion is given, so that you can refer to. And there are a lot of online ebooks are available, so which you can download and you can study about the Arduino platform. So resources are not uh, constrained. A lot of since it is open source, a lot of people have developed libraries and open source material. So you can study and you can incorporate, even the ready projects are there that you can take use directly and study by this particular community, right? So this is how the books are available. Again, we have short break before you attempt any small programming part for our this Arduino discussion, right? So this is the last break that we are giving, and then we will complete the next session, the remaining part of our discussion. Thank you. So we'll have 10 minutes break now. So 1:15 is that. So we'll meet at 1:25 again. 1:25. But kindly be note this particular time. 1:20, 1:25.
કેવલી અવાજ નથી વોલ્યુમ વિડીયોમાં.
Okay. Aman bhai.
હેલો કેવલિયા,
હા.
ઓડિયો વિડીયોમાં અત્યારે નથી જ કર્યો, એટલે ઓડિયો ઓફ છે.
Okay. Okay.
Only
Okay.
video.
Okay. Sure. Okay. done.
So shall we start, guys?
Sure, sir.
Am I audible?
Yes, sir.
Okay, okay, fine. Is my screen is visible?
Yeah.
Hello? Yes, is my screen? Okay, fine,
Yes,
fine.
sir.
So let me start our last session where we are having on the discussion of the Arduino programming. So in the previous two sessions, we have concluded about the area of robotics where you can use the Arduino platform hardware, which is popular open source hardware platform available in the market. In second section, we have seen about the Arduino platform, its resources, its microcontroller, and the basic basic fundamentals about how we can use this for our robotic application. But the important session today is the Arduino programming, where you can make that board or motherboard work by using the software, which is actually essential for uh, doing our board active, right? So without that software, your board is simply a dead body. So, but to make it some activity on the your robotic application, you need to have the software, which is been designed by you for your entire logic, right? So you might aware about the programming language like C, C++, which are the programming language which are used in the computer to make your program, right? So in the Arduino programming, basically, what we will cover is the what is Arduino programming, what is digital input output programming, what is analog input output programming, how we can have develop the software for serial communication with the Arduino platform, and how we can write a program for sensors to convert analog value into digital. So it is ADC interfacing we will carry out in the programming. Right. So we will look at to this programming aspect, and then we will also see the hardware demonstration as well as the tinkering simulation with the Arduino platform, right? So that we will carry out in this 1 hour, next 1 hour. Anyway, so we will have the so you can see in this particular picture, which is taken from the at UC Berkeley, which is I got from the internet site. So you can see here how we can have the Arduino platform, which is used to have some sensing of the sensors, and you can have the output generated by Arduino platform, and you can generate some actuation by using the actuators like motors and buzzers. You can interface. So in this picture, what you can see here is the some sensors are there, that is input transducers, which is level sliders are there, which are connected through Arduino platform via one breadboard, which is look like below the Arduino platform, and these sensors are connected with wires to the Arduino platform, and likewise, actuators, the motors and buzzers also connected through Arduino platform through breadboard connectivity. Some peripherals and ICs are there connected on the breadboard, and this Arduino platform is interfaced with your computer system on which your Arduino IDE or the Arduino software is installed. So this computer system is basically used to develop the program on the Arduino platform. And after developing program, after compiling and testing, you can download your program into Arduino platform, and you can see the behavior of your program on Arduino platform and your job done. Right. So this is the way. So your computer system is used to program the Arduino software, right? And then you can disconnect also, and you can connect power externally to the Arduino platform, and you can make your system autonomously work. So the program which you have burned into Arduino platform is getting executed autonomously, even though your computer system is disconnected, right? But basically, for programming Arduino platform, you require computer system, right? So this is how the basic block diagram that you can see from this picture, right? So I think you can understand that very easily the position of the Arduino platform in one of the applications. So you can assume here that in the left hand side, instead of this mechanism, you can plug your robot, right? So your robotic sensors, robotic actuators, you can control through Arduino platform, and you can develop the software on the computer system. So what you can start with getting started for Arduino programming is you can download an IDE. It is called IDE, Integrated Development Environment, from this website, homepage of the Arduino.cc, and you can install it on your computer. Then you can connect the board to your computer via USB cable. So you need to purchase one cable also, which is USB cable, which you can connect with your computer system. If needed, install the driver. So each Arduino platform have its driver, which is also available on the website, which you can download and you can install on your computer to get it detected that board on your computer system. Okay, so that is one time you have to do. Like your pen drive is inserting on your computer system. At that time, the driver is being installed by operating system and your pen drive start working. Likewise, you require driver for connecting your Arduino platform with the your computer system, right? So for that, you can download driver as well. First time installation, then later it is not required all the time. Then you can launch the Arduino platform, Arduino IDE on your computer system. Select your board from the option given, tools option given that on that software. I'll show you this screenshot of that as well. And select your board, select your serial port number, and then let us open one first program of LED blinking, and you can upload the program by clicking on that upload button, and then you can see your program get burned into platform and your program LED blinking is working, right? So that we will see just now after some discussion. So here the picture screenshot of the Arduino IDE. It looks like this. So this is the how the button toolbar is there. Then there is a compile option is there. Then download button is there. Opening sketch is there. Upload, download. So while you interact with the software, you will find this button. So first time you will see those buttons by clicking on those buttons. What are these buttons given and all those things. But some discussion is needed while you interact with this particular software. So we are within 2-3 slides you will come to know about what are the buttons. You can see here that select the serial port and board. So this is how the you can open this software and you can select the serial port. So COM12 or COM11, whatever is been detected by the device manager of your computer system. So that will run after installing driver of the your Arduino platform, and you can detect that in the device in control panel. You can go on device manager, and in device manager serial port you will find Arduino Uno platform detected on particular COM port. So that port you need to select in the software before you start working on this particular platform, right? And then in the second option you can select the board type, right? So board is Arduino Uno is selected in the second picture, and then on the left hand side you will have the port selection, right? So port is been detected by the device manager if it is the driver is being installed first time. So this is the screenshot of the first time setting up the Arduino platform on Arduino IDE, right? So these two things that you need to do before you begin to work with the hardware. So these are the various terminology that you can have on the software. That is Sketch. Sketch is a new program, a program you write to run on an Arduino board. that is known as sketch. So while you are working on computer system, edit the C code in the editor. Likewise, in the this is called C file in the programming language C. While in Arduino, the new file is termed as sketch, right? So that is how you need to understand. There is one button of sketch as well. So by clicking on that button, you can open out that sketch environment where you can code your Arduino program. Then pin, an input or output connected to something, right? So there are GPIO header is there on the platform, which you can have the termed as a pins of that particular. So you can connect LED on that pin or input from the some of the input device like knob or potentiometer or something like that. Then there is a digital value is high or low. So if there is a single bit digital value, then it is 0 or 1, that you understand. So high means plus 5 volt and low means logic 0, ground, that is 0 volt, right? 0 volt and 5 volt is termed as logic 1 and logic 0 in case of digital, right? So, and in case of analog, you can have the values usually from 0 to 255. So if it is 8-bit data bit, then 2 raised to 8, that is 255. So total 256 variation is possible in the digital. So analog value is converted into digital by means of this 8-bit number, right? So these are the various terminology. While we use programming, we will do programming. This terminology are preferred by the software ID. This is little bit about programming. Code is you can learn these things by experiencing working with the Arduino programming, but this is a case sensitive language, so you can have capital or small case sensitive character. Statements are commands and must end with an semicolon. So it is similar to that of the C programming language where the syntax is end with the semicolon syntax. Then comments follow a double slash or begin with slash star and end with star slash. So this is again similar to the C programming language, and this is how some basic thing that you need to know before you attempt any small program for your. So what is the bare minimum code that you can get from the sketch of the Arduino? So you will find two functions readily available, which you can simply see in the opening new sketch. One is void setup function is there, which is clubbed, the logic of the setup function clubbed into a two curly brackets. So put your all setup code here to initialize the various peripheral, and it is running once only while your program starts. It is executing the setup function. And second is the void loop, which is actually continuous execution of the syntax is clubbed within this curly bracket of loop function. So put your main code here to run repetitively by your Arduino platform, right? So whatever you wish to do through Arduino platform, the logic should be clubbed into a loop function, right? And that is how you can have the two bare minimum things you will get in the new sketch of the Arduino software. Now, bare minimum code, what is stat of that we have discussed already. So we'll just proceed how further. Now, what you can your first this thing attempt to work with the Arduino software. So you can have the write your sketch, new sketch you can start with. Then after completing program, writing of your program, you can press the compile button. So you can see on right hand side there is a flow compile button is there, which you can also see in the that toolbar of the Arduino IDE, and then you can simply press upload button to program Arduino board with your sketch. So after getting message, after compiling the program, you will get the message done compiling. If there are no errors are there, then done compiling. Then you can have the second button, that is upload button. So which is actually used for downloading your generated program into Arduino platform, right? So once you do that, you will find that program is getting burned into your Arduino platform. Then you just reset your board. Your board is executing the code which you have written on the computer Arduino IDE, right? And then you can see the effect. So for having the first experience with the Arduino platform, what you can do is you can open the readily available example of LED blinking in the sketchbook examples digital blink, and you can see burning this program into Arduino platform. You can see that LED get blink is available on board. So this is the experiment which we can carry out very easily after purchasing your board, and you can just simply open the example available and you can make your board working. So I have just burned one program, LED blinking program, that I will show you in my video. Just now I'm just trying to interact with this particular through my mobile phone, and let us see, you can see this thing or not. Let us try it with my mobile phone with you. So let me just stop sharing of my desktop and I will try to look at my sharing of my mobile phone screen, and let me have this. So, see it? Can you see? Okay. So can you see that video?
Yes,
Yeah.
sir, it's visible.
Okay. So just okay. Anyway, so this is how my first program. Uh, okay. So this is my first program. Why it is this? I don't know. Can you see this? So this is how my program is downloaded.
મોબાઈલ એમ પટેલ
Yeah. Yeah.
તમારો મોબાઈલ સીધો જ રાખો, આ આડું દેખાય છે એટલે હા
Okay. So you can see that this Arduino platform in which I have linked an LED by downloading the first program of this LED blinking available inside the Arduino IDE itself. So you can see I'm just changing the delay to this particular function, and I'm reloading the program into this particular development board, and let us see whether it is having
DM
some
show
impact.
your code also. DM
Yeah.
show your code also. We are not we cannot see the code
Okay. Okay.
screen
Okay,
of
I will
your
do that.
laptop.
So I am burning. Actually, I am burning the program. So just now it is start burning. Can you able to see? Vinay sir? So it is just now
Arduino
uploading.
board.
Yeah, yeah, I will show. I will show. Okay, see, I have made the instead of 1000 millisecond, I have made 200 millisecond. Now it is affected with this delay. So you can see that LED gets blinked very quickly. So this is how I can modify the program inside this particular development board. So I hope that you got this idea how we can burn the program of first attempt to this experiment board with the Arduino platform. So I am just switching again to the our discussion on the our PPTs. So let me just stop the. Okay, is my screen is visible now again? Is my screen is visible to you now? Yeah.
Yes,
Yes.
sir.
Okay, fine.
Yes, sir.
So that is how we can have the first program with the Arduino platform. You can start with without connecting anything. Only simply one USB cable. You can purchase a board. You can interface with the Arduino IDE, and then you can open the example from the basic example folder, and then you can run that program after compiling it. So that will make your LED blink first program into this Arduino hardware, right? So that attempt you can you'll have to do while you first begin with your Arduino platform. Now let us discuss few of the things, basic things for programming, and then we'll look at two other aspects. Basically, digital I/O is a binary valued. It's either on or off, one or zero. Internally, all microprocessors are digital because our digital technology is evolved in such a place where your controller is also having the digital number activity. So we need to study about how digital things work. So this is IO pins. You will find that two states, binary signal, multiple state continuous signal. So digital pins input outputs are on the upper port of the this particular platform, and there is a analog input pins are there on the Arduino platform, which is shown by the red color. This you can see on the platform, Arduino platform as well. Then we can also change the mode of the pin by having the function called pin mode. A pin on Arduino can be set as input or output by using pin mode function. Pin mode, you can have the function, you can pass an argument, the pin number 13, and you can make it as input or you can make it as output. So here in the first function, pin mode 13 comma output is setting the pin 13 as an output pin, and pin mode 13. Hello.
Patel,
Yeah, bolo, bolo.
please put your presentation in PPT in presentation mode.
PPT in okay, sorry. Thank you, sir. Okay, so you can have the pin mode is 13 for input. You can set that pin number 13 as input pin, right? Reading and writing digital values. So you can use this function called digital write 13 pin number low. So you want to write something on digital pin number 13 low, then it makes the output voltage on pin 13 to 0 volt, right? And digital write 13 to high, it makes the output voltage on pin number 13 to 5 volt. And you can get the status of the pin as well from some of the pin. So integer button state is the variable name, is equal to digital read function and into bracket 2. So 2 number pin state is been copied into the button state variable. So you can take some programming decision based on this button state in the Arduino programming. This is Arduino digital I/O. So you can see here in this picture, there is a CPU connected with the pins outside, and there is a internal bit storage. Each and every pin is having the storage register inside this particular pin, and you can store these values by having the software syntax. You can set the pin mode, you can digital read the pin, you can digital write the value to the pin, and some of the electronic stuff is required so that you can have the complete electronic system you can develop externally to interface with the Arduino IO pins. Let me discuss about the LED blinking program hardware. How we can connect the hardware with the this particular pin of Arduino platform. You can have the LEDs have polarity. So when you buy this LED from the market, there is one nomenclature that you can follow. That there is an anode and cathode. Basically, LEDs are nothing but a diode, right? So diode have the anode and cathode. So if you want to blink an LED, the anode should have high voltage and cathode should have low voltage. So generally ground is to be used for cathode, and plus 5 volt or 3 volt is to be used for anode for making it blink. If you do reverse, then this LED gets off, right? So negative indicated by flat side of the housing and short leg. So short leg is negative and long length is positive for this LED. You can see on the right hand side picture, the Arduino platform, one LED is connected onto the jack. It is simply connected on the port where you can have the connectivity of this particular LED. So this LED in the hardware is been connected if you want to interface with the Arduino platform. So there are two ways you can interface an LED with the Arduino GPIO. So you can see in the first picture, left hand side, that pin number 13 of Arduino platform is connected to anode of the an LED with one resistance, and cathode of that is connected to ground. So suppose if you want to glow this LED, so you need to give pin number 13 is logic high by having the software syntax digital write pin number 13 too high, then it is glowing the LED. But if you want to disable this LED, you write the software digital write pin number 13 to high, low. So when you do the low on the pin number 13, then at both the end there is a 0 0 logic, so this LED won't glow. In the another way, you can say that if you want to disable LED, then you can just pass pin 13 as logic 0, and if you want to enable LED, you can pass logic 1 to this pin number 13. On the other hand, on the right hand side, you can see the picture where pin number 13 is connected to the cathode of the LED via one resistance for controlling the current, and anode is connected to ground. So suppose if you want to, anode is connected to plus 5 volt, that is VCC. So if you want to glow this LED in the right hand side, you need to connect. You need to write a pin number 13 to 0, right? So if you write 0, that means it is connected to ground. So VCC is drawing current from LED and to ground, and your LED will glow. But if you want to disable this LED, then pin number 13 requires logic high. That means high voltage. So that stop the current between 2 points, plus 5 volt minus 5 volt is 0, and no current is flow, and LED is off. So it is exactly reverse version of the two interfacing that you can carry out with our Arduino platform. So it is basically known as the syncing mode of LED interfacing and sourcing mode of LED interfacing. So basically syncing mode of LED intensity giving you more brightness than that of the sourcing mode, because for microcontroller, sourcing capacity is less than that of the syncing capacity of the Arduino platform. So it's preferable to use the second right hand side choice, where logic low is required to make enable an LED, and logic high is required to disable the LED. And you can see in the software loop as well, you can have the digital write LED pin high, delay of 500 milliseconds, digital write LED pin is low, and delay of 500 milliseconds. So this is hardware connection required while you attempt this LED blinking program externally interface with your Arduino platform. This is our first program that we have seen just now on LED blinking program. So while you open this program into Arduino IDE from the examples basic blink program, you can see here that it is setting up the pin mode 13 as output, which is actually the 13 number pin one LED is connected. If you remember the first introduction to the Arduino platform, 13 number pin is connected with onboard LED, that is to be part of the LED on the board. And in the loop, you may write 13 number pin as high, then wait for 1000 millisecond delay function, that is approximately 1 second, then digital write 13 to low and 1 second delay, and then you remain in continuous loop. So that will blink your LED on board itself, right? So without any hardware interfacing externally, you can run this program into platform, and your LED blinking program gets started. So basically delay function, digital write function, pin mode function, these are all readily available functions in the libraries of the Arduino that you can use for development of your Arduino program. So this is the program which you can start with after procuring this Arduino platform. Basically, there are two delay functions. Delay we can use for millisecond generation by passing an argument number, and delay microsecond for having the small time resolution. It causes the in terms of microseconds that you can use for your this thing. And we have also seen the demonstration of this variation in the delay in our programming. Okay, even you can control the brightness of the LED by using PWM technique that we will see with the analog write functionality which is there in the and you can have the hardware connectivity of this LED externally to this one resistance, and then there is one LED is connected, then supply is connected, and ground is there. So this is how you can build an LED interfacing with the Arduino platform by using breadboard and resistance, and you can have the activity of brightness control of the LED. So how we can control the brightness of an LED? So what you can have is if you control the current which is passing through LED, you can control the brightness. So you can see here that in the 23% brightness having the low current, and 100% brightness requires the high current to pass through this LED. So which can be controlled through software as well in the Arduino platform. So how we can control the brightness? So by using pulse width modulation technique, you can do that. So what you can do is that you can provide one pulse waveform of control time period to the LED, and if you control the on time to high and off time to low, then you can increase the brightness. So you can see in this picture for particular time period T, 75% of the pulse is on and 25% of the pulse is off, which will generate 75% brightness of the total final brightness. Yeah, same way, if you do 50% high and 50% low, then you can have the brightness of an LED, which is 50% of the final brightness. Likewise, you can reduce the pulse width to 25% to generate the brightness up to 25%. So you can see here that the percentage of the on time and off time can be controlled through the delay routine which you are using in the Arduino software. So by controlling that on time and off time, you can control the brightness of the LED, right? So this is the technique which is used in motor control application as well. In the controlling of the speed of this motor, you can use the PWM technique to control the current which is passed through the DC motor, and you can control the speed likewise. So this is very good technique. It is very popular among the microcontroller driving. So this is how we can have. So again, this is giving you the idea how this voltage is converted into variation in the analog voltage by controlling the pulses 25, 20%, 50%, 75%. You can get 1 volt, 2.5 volt, 3.75 volt. That is because that average voltage is equal to the on time divided by cycle time into final voltage, right? So that is giving you the average voltage, and by varying the percentage of bit, you can change the voltage variation at the output of the your pin, right? So that is how you can control the brightness of the LED. So these are the pins available on Arduino platform itself for PWM output. So pin number 3, 5, 6, 9, 10, and 11 are readily giving you the pulse width modulation signal by using the software functions which you can use for your controlling purpose. And now we'll look at some of the things on the serial communication, because this is also very easily established on the Arduino platform. So you are using actually the same port which you have interfaced with one cable through USB cable, and this cable is used for programming the Arduino platform, as well as you can use it for checking your serial communication with your Arduino platform. So basically, serial communication is the protocol for sending data digitally to one system to another system with the serial data. So it is not parallelly connected, but one serial cable is used for sending pulses 0101. So you will go in more detail about the serial communication facility, but as a user of the Arduino platform, one can readily use the function of serial communication to get it communication between two pulses, right? Two systems. So we'll not go into that much detail as not required at all for using this serial port, but you can simply have the functions you can use for your serial communication. And after writing program for serial communication, you can monitor the serial port in the IDE itself. That is, you can have the one serial monitor option. You can click on that button. You can see that on the another window, you will find that serial port data is being displayed, and you can monitor the data which is sent by the Arduino platform. These are the various functions that you can readily use for having the serial communication. Serial.begin function, it start the serial communication, and you can also use serial.begin at into bracket 9600 baud rate. Varieties of baud rate you can set at both the ends same, so you can set that baud rate. You can display that into the serial monitor function by using serial.print or serial.print line. So these are how the various functions: serial read, serial available, serial write, serial pass, and integer. So depending on your usage, you can go on studying these functions on the website itself, and you can incorporate into your design for communication purpose. Then last part of this programming is the discussion on analog to digital conversion. So we can convert any sensor value continuous one domain into digital data, as our controller is digital. So we require to convert that value into digital one, and we need to recognize that. So there are six analog channels are there that you will find on the bottom of this Arduino platform. The A0 to A5, these are the six analog channels to which you can input data continuous voltage, and you can convert into digital by software function inside Arduino platform. So what is actually ADC will do? It is converting 0 volt into 0 digital value, 2.5 volt into 127 digital number, and 5 volt maximum into 255 digital number, because it is 8-bit data which is read by Arduino. So 8-bit data having the maximum value is FF, that is 2 raised to 8. So 256 is the maximum value. It is corresponding to 5 volt, and middle value is to 127. It is corresponding to 2.5 volt, and 0 volt is equal to 0 digital data. So this is how analog value is to be understood by Arduino platform by using analog to digital converter channel and converting into a digital one. The Arduino Uno board contains 6 pins for ADC, 10-bit analog to digital converter. So it means that it will map input voltage between 0 to 5 volt into integer values between 0 to 1023. So 1023 is come from 2 raised to 10, right? So that is how you can have the more resolution than 8-bit value of the analog output. So this is how analog read function is there. Simply you can just select the channel A0 and write a function analog read that to have the reading of A0 channel, and then you can write something on also on the analog write function. So the 2 number pin you can write 128, that is equal to that analog equivalent output generated by the analog write function. This is a simple program for having ADC interfacing, but those who are interested, they may refer to this ADC example in the ID itself. But right now it is not required to discuss in more detail. It is as and when required, you can go on studying. So before wasting much time, I'll just switch over to our TinkerCAD software, where you are actually going to test your uh, actually Arduino code, and then we will have the hardware demonstration also. So what is TinkerCAD software? It's basically a great tool which I have recently come across. Dr. Vinay Patel sir have suggested me this software to have the working with the Arduino platform. So I also come to know, and I understand that it is very good software for simulation tools to begin with Arduino platform without investing anything into the hardware. So straight away you can just open your internet, and you can on the browser itself you can run your Arduino based software software testing. So tool running on internet browser www.tinkercad.com. A lot of peripheral libraries are available. Circuit design and simulation and testing of your Arduino logic on the simulator, and programming in block also supported, and it is also giving you text based programming, that is our normal Arduino programming, or both is also supported by this particular browser. So basic CAD design also possible with which file can be input to a 3D printer. So you can have that. So another workshop that we are going to have on this 3D CAD design with the TinkerCAD. And let's start to interact directly with the TinkerCAD browser. So I'm opening browser on my desktop, and we will see that how we can work with the TinkerCAD software. So you can see here that my window is, I think, visible to you. I have already logged in through my login ID. It supports Google email address also, or you can create your own login and you can start with this particular software. So let me just try to begin with TinkerCAD. So you can just Google TinkerCAD. You can have TinkerCAD software, and you can see that tinkercad.com website is visible. So is my screen is visible? Okay. So you can see after getting this software on this particular thing browser, I have already logged in, so no need to it is not asked me that about. But you can see on this particular left hand side, you'll find circuits block is there, where you can see there are a lot of programs, and you can have the experiment with. So what you can do is you can have the click on create new circuit, and it is opening the environment where you can write your you can drag your circuit. So let me have the first readily available LED blinking logic that we have already seen. I'll just drag this particular link design over here directly in this particular environment, and you can see here that there in the, and their LED is connected to the pin number 13 via one resistance, which we have seen in the diagram, and another end is connected to ground, right? So this you can do also, but I'm just taking one sample which we have already seen. On right hand side top, you will find there is a code option. You will see that there is a code option which you can select block based code, or you can have the text based code.
Patel,
Hello.
Patel,
Yeah.
can you show them that how these components are drag and drop?
Yeah, I will show. Before that, I will just want to simulate the LED blinking hardware that we have seen.
Okay.
I will show
Okay.
that later. Yeah. So you can see here that by opening this particular readily available example, in which I can see that same program of LED blinking over here, right? And instead you can also select the block-based programming. Likewise, you can have the blocks readily available that you can drag and drop into this particular environment, and you can have the editing of this particular coding. But to do before that, I'll just start simulating this particular program on the browser. So you can see here that LED get blinked into this browser itself as per the code that we have done. And you can see that again the same amount of delay is been provided. Now just I want to vary again the same thing in the logic which we have already tested on the hardware. So what I will do, I will just make that 1000 millisecond delay into 200 millisecond delay, and then I will just do simulating again. So you can see that rate of blinking of an LED is increasing. So the delay time is less, and your blinking rate is now increasing. And at the same time, what I want to also show you that the LED available on the board also get blinked because it is the part of 13 number pin, and the external LED is also connected to 13 number pin, and both LEDs are getting blinked through this particular program. Right now, you can also do the block based programming. So what you can do simply, you can have the choice of block based programming. So what I will just delete this particular block again. So delete block I will just do, and just right click and right hand side to blink stop the LED. Now what you can do, you can select this block and you can drag into this particular environment. Now there is a control block is there, which is of orange color. Wait for this particular block. Then again, your LED is to be connected after wait, and then you can control again delay through this wait loop, and then you can make that LED low, and then after 1 second delay, you can have 1 second delay and make LED high. So this loop is equivalent to this particular code, which is also you will find it in the this particular text base. Now you can, after that you can simulate it and you can see the effect again. So there may be some error. Okay, so it is start running. Your program is running, and this is the way you can attempt this programming in the block base or in the your text base, right? So this is the way you can have the simulation activity. So why I have shown you this is because this thing we have done in hardware, and in software you can see the same effect by simulating it. But suppose if you want to connect one a peripheral, then what you can do, simply you can have delete this particular block. So instead, what we can do, we can just begin this new program, and we will have choice of basic component, and then we can start interfacing. So I'll just selecting this LED resistance LED, and then I will select the Arduino platform, our basic Arduino platform, and again I can join this with the wire. So same program, same logic, uh, the LED blinking program which we have developed in the hardware, which I will interface with the software. So instead, you can see here that 13 number pin you connect to this one of and of the register, and then you can interface this like this, and then you can also write a program. But while you working with this particular LED blinking, it is giving you the default program which you can modify, and you can have the your this thing logic you can vary, and you can edit that program as well, and we can program as per our requirement. So after connecting this, you can see that your LED gets blink in the environment. So you can drag and drop any components from the library. Like there are so many basic components are given. Registers is there, then LED is there, push button switch is there, potentiometer is there, capacitor is there, then battery also is there, coins and battery is there. So instead, suppose if you want to do some activity with uh, this other peripheral like battery, then also you can interface with this. Let us say this ground is connected, negative terminal of this battery is connected to this one end of LED, and other end plus voltage is connected to the resistance of this LED. Then you can also test by running the program. So you can see that LED gets permanently on because there is supply battery is there. There is no programming device. If you look at the code as well, no programmable components in this circuit is available because there is no microcontroller, right? So microcontroller is responsible for executing the program, but it's not. Likewise, you can drag the breadboard as well, where you can have various connectivity. You can do this connection, and you can have use of this breadboard for your interfacing purpose. So this you can do. There are 1.5 volt batteries there. Then there is a vibration motor is there. Then hobby gear motor is there. Ultrasonic sensor which we have seen is there, which you can use. There is a temperature sensor is there. You can connect, use. Then there is a multimeter. It's an interesting thing that you can connect the multimeter wire to measure some of the point voltage, and this thing we can go for. And apart from that, it is having strong library where you can have readily available boards are there, which you can directly use for. So let's say, for example, I will just show you the example of LCD for for having the, let me just go in the beginning. So I can delete this and I can open the readily available function, readily available block of this particular thing. So I have just chosen one LCD program, LCD block. You can see here. Here, let me just back. Okay, so yeah. So you can see that this LCD readily available sample where LCD is interfaced with Arduino platform. You can just simply run this particular program, and you can see that Hello World is to be displayed on the this particular board. So while you can also change the logic that you want to change. Let us say instead of Hello World, I'll just display Hello Vinay sir. Let me have this. Syntax that I just compile, and after editing this code you can see after initialization hello Vinay sir is being displayed. So just simply dragging this particular component and interfacing, you can simply play with this particular example. Likewise, you have also the one ultrasonic ranger, ultrasonic rangefinder also project is there. So that also we can carry out. Right. So let us say, let me try this happening. Yeah. So this is how ultrasonic ranger program is also given, which is readily available. So if you do that. Okay, anyway, so I'll just go in the text-based programming, and then I will just start running the simulation again. So you will see here that there is a button called serial monitor. That this serial monitor you can turn on, and you can see that I'm clicking on the ultrasonic and changing the object position. You can see the value of the serial monitor output is getting changed. So basically, you are playing with the simulator, and you can see the effect in the output. And at the same time, you can also look at to the code. Okay, so this is how the code for interfacing ultrasonic sensor with Arduino platform, and you can do this particular thing very easily. Right. So there are so many examples that you can get, and you can see here in the this library which is already given. There is a servo motor example is also given, so that also you can play, and you can learn the how we can study the servo motor this experiment, and you can write a program for that as well. So you can see here that servo motor program is rotating the servo motor by having the interfacing. At the same time, you can see the this particular code of this particular servo interfacing in the text change, and you can just look at to this after running the code also it is visible. So there is a loop, so first of all library inclusion of servo motor, and there is a setup particular pin where servo motor is interfaced, and there is a for loop for having rotation to 0 to 180 degree reverse way. So likewise, whatever things happening physically in the simulator, which you can also study through our software. So this is how we can use this particular TinkerCAD software to interact with this particular activity of making or learning programming with Arduino. Even this browser can run on the mobile phone browser also. So instead of using computer, one can also study the programming on the mobile browser by accessing the TinkerCAD software. So this way you can learn the Arduino platform on TinkerCAD software without investing anything, and you can develop and learn the program. So I think you have get an idea. So there is a actually the time is limit. So I will not go into that much detail about this particular software, but one can easily start and begin with after this much discussion, and we can have the start working with this particular Arduino platform. So whatever things which we can simulate then can be implemented later once you have the resources available with you. So for that understanding, our students have developed some of the experiment with the Arduino platform. Rishikesh, Vegad, and Jai have developed this thing. So I'm just handovering this particular session to them to show you the demonstration, actual hardware demonstration which they have since morning. They have started interfacing, and at this at within 2-3 hours they have implemented this particular experiment. It is showing you and explaining you what they have done, and that's all from my side. So thank you and best of luck to you. So I'm handing over sensor to session to the Rishikesh, and they will show you the demonstration, and then we'll attempt 5 minutes question answer. Yeah, yeah, yeah.
DM, before the Rishikesh and Jay starts,
Yeah, yeah.
address
Hello.
the questions.
Okay. Let me address the questions first.
Before you hand over to Rishikesh and
Okay,
Jay,
okay. No
uh,
problem, no problem.
the students can ask the question,
Yeah, yeah,
query,
yeah.
whatever.
Yeah, yeah, yeah. Let me have for five minutes.
So there's a question.
Yeah.
Is Raspberry Pi a microcontroller?
Raspberry Pi is the microcontroller with OS installed on it. It's a microcontroller with operating system. It's a small computer. Get it? Isn't it? Are you getting the answer? Raspberry Pi contains Raspbian OS which you can install from internet, and it is open source. It is operating system based small card size computer. It is along with microcontroller, right? Arduino platform is only microcontroller.
Okay,
Any
sir.
other any other
No,
query?
sir. No other doubt.
Okay,
Rishikesh, now we can take over.
okay, okay. So Vinay sir, we will hand over to the Rishikesh and Jai for having hardware demonstration. So I am stopping my screen, and Rishikesh, can you involve?
So here we have prepared.
देखा तो हाँ देखा है।
So we have prepared three projects. That the first one is with IR sensor. We have just taking the inputs from the IR sensor and blinking the LED that is on and off. So if I do this, and the I have a sensor will take the input, it will sense, and then the LED will be off. And when it will not, it will the sensor will not sense, then the LED will be blow. So here is the code for that. Now our next project is the ultrasonic sensor. Here I am going to open the ultrasonic sensor program. So when we check the output in the serial monitor, oh, I'm uploading the program. Yeah, it is done now. So when we check the outputs in the serial monitor, so you can see the variations here at the ultrasonic. Here you can check the variations. These are all in centimeters. So, so you can now do this at your own, and it is simple to check the distance from by ultrasonic. And the last project is the potential varying the voltage with potentiometer. Here is the code. I'm uploading the program for potentiometer. This is the potentiometer. Right. Here is the potentiometer, and by varying it, we are just observing the voltage variation. Here you can see doing this zero, we're going for the zero voltage. Yeah, so digital zero and voltage is also 0 0. And now, as we are increasing the voltage, the digital value is also increasing, and at the end, the maximum voltage will be 1023, and the maximum digital value will be 1023, and voltage will be 5 volts. As our microcontroller is about the 10 bit, so 2 to the power 10 is 1024. So maximum value will be 1023, and the voltage will be maximum 5 volts. Yeah. Okay, Kevalia, that's all from our side.
Amazing presentation, Rishikesh and Jai Goswami. Oh, thank you, DM Patel sir, for showing us infinite possibilities Arduino holds for us. To all the
1 minute,
attendees.
Kevalia. 1 minute,
Yes,
Kevalia.
sir.
Uh,
Yes, sir.
uh, Still, there is question. Can raise the question, queries, whatever it is.
Yes, to all the attendees, your questions are welcome now as well. Feel free to clear all your doubts regarding to this session.
Is everybody satisfied? Those who have attempted first time with Arduino? Anyone first year students is present here? Anyone first year student?
There are many first year students in the meeting.
So give one of the student feedback at least.
Anyone who would voluntarily like to speak about today's session? How was it? Did you like it or not?
Yeah, 23401
Yeah.
is the first student.
You give your feedback so that we can improve upon.
Vinay sir, can we request any one of guy from mechanical? 20 ME 435 or somebody?
I don't know by the ID number.
Because I think interdisciplinary students can give more feedback.
Okay, no problem. We can conclude the session.
Yeah. Okay.
First of all, I would like to invite Professor Vijay Pratap Singh sir to deliver a vote of thanks as we proceed to the end of today's workshop.
Okay, good afternoon, everyone. I Vijay Pratap Singh, Assistant Professor, Mechanical Engineering Department, on behalf of TRS BVM Student Chapter Team and BVM Engineering College. Like to present the vote of thanks to our today's expert speaker, Sir DM Patel, sir, who has enlightened us with his knowledge. And I feel today's lecture was full of knowledge, and sir has very nicely explained the Arduino board and how in the era of this industry 4.0, basically the industries are moving towards the automation. So ultimately, if we are knowing these things from the beginning, for particularly if we are talking about the first year students, so that will be a very great thing for them. And I'm pretty sure that the precious knowledge that is DM Patel sir has given us definitely help us. Thank you, DM Patel sir, for taking time from your busy schedule and enlightening us with your knowledge. And I also like to say a vote of thanks to our convener Vinay Patel sir for constant guidance for organizing such workshop. and our student members also for their continuous support during the program, especially Rishikesh and Jay for preparing the live demonstration available. I would also like to thank Principal Indrajit Patel sir for permitting us to organize such workshop. And last not the least, all the participants who had paying attention and getting some learning from this. By the support of all the participants, we make this workshop successful. Thank you all. Thank you very much.
Thank you, Vijay Pratap Singh, sir. I hope everyone enjoyed an extremely informative session this weekend. We are looking forward to organize more of this if we receive a positive feedback from this one. Thank you for being a part of an amazing journey we have just started together with TRS BVM student chapter. Thank you so much.
Thank you all.
Thank you. No.
Hello. Uh, if you want to become a member of TRS Student chapter, you can mail us the fill form and we'll forward it as the link. Okay. Thank you.